Okay, now let's develop the simple fixed point script in Matlab. So open the editor window by edit command. So first of all, I can write because in this fixed because now remember that the fixed point method is an open method, so we don't need to bracket the root, so we just need one initial estimate. So therefore we will choose the stopping error es and the first input as xi, and in the simple fixed point method we will input the function f in the form of x is equal to gf. So if the function is equal to if the function f of x is equal to 0, so we will rearrange this function in the form so that we can write as x is equal to gx. Okay, so on the left hand side will be x and on the right hand side is gx. So suppose we take the example of this function f of x is equal to exponent of that is e power minus x minus x, exponent of x minus x. Okay, this is the function which is the same example in your that is in your textbook. So this script is we can start as before. This we can specify the stopping error yes is equal to, say, whatever you can take, it's up to you, maybe just take 1%. Okay, yes is equal to 1. Okay, and then I will be for the iteration. Okay, I is the counter for the iteration, so we will start from 0 in this case. You can even start from 1 as well. So so I is equal to 1. So for I is equal to 1, and then we need to have some starting value of this function, the starting estimate of the root of this function. So starting value we can take xi is equal to 0 in this case. Okay, just say we start from 0, we start evaluating from 0, and next we want to print because what we want is we want to print the values in the form of a table. So the table headers we can print like this in this form. I want to print these table headers. So you can use fprintf command, iteration, xi, that will give us the root, fx the value of the function, and then ea is the error estimated error, and then /n for the new line printout. So the next command which you can put is in the first line of the table I want to show this control F. I want to show this, so I want to show just two values, I and xi. Okay, I is the iteration 0 and xi is the initial value, and of course there are two more columns, fx and ea, but at this moment I don't want to show them. I is the integer and xi is the initial estimate. Okay, so at this moment I can test this function, but first I need to save it. Save fp lab. Okay, fixed point lab. Okay, and then maybe fixed simple fixed point lab. Okay, anyways, fsf point lab. So let's test it. Okay, so export in lab, unrecognized functional variable example error in spotlight line 3. So there is something missing over here. Yes, because I wanted this to be the comment, so I should start it with %sign. So I save again and now run. So now in this case, iteration xi, this is the first row of the table, and the first row of the data is zeroth iteration, and we are starting from 0th value. Okay, so of course this is just for the start. Now we can check the next value. Next value is we need to define these functions g and f. Okay, so the function g is in terms of x, so we use the anonymous function format g @x, and then because this function is e power minus x, so because this function e power minus x can be written as x is equal to e power x. Okay, so x is equal to e power minus x, so it can be written as exp minus x. Okay, so where x is a variable which we can use. And next is f. So f is equal to, also in terms of x, f is also in terms of x, so it is exp minus x and then minus x. Okay, this is the function f, and then enclose it with the columns. So yeah, with this, now what we can do is we can now calculate the estimated error. Right, so EA, approximate error. Okay, approximate error we can calculate because in this case the function is in the form of gx, so the updated value of x is actually gx. Updated value of x, that is the estimated value of x, is gx. Okay, so that is the new root is gx, so g in times of, so x I, gxi, so this will be the gxi, this is the updated value of xi, and then subtracted from that the value of xi. Okay, the value of xi divided by g of xi, and then bracket, and then we should take the absolute value, so abs, and then we should put a value over here, parentheses, left and right parentheses, we should put 100 and then colon. So in this case, in this way we will calculate the absolute error. So, and then with that I can increase the value of the counter, because now I am calculating the new value of the function in terms of g of x. Okay, and the new value of x is also in terms of g of xi. So the value of the iteration will be also increased by 1. And now I can print the new values. This will be the second column. Okay, this will be the second column. Sorry, the second row output. So the second row output can be written like this. So in this case, f print, and now what I need to put what I need to print is I iteration gxi. This is the estimate of the root according to the simple fixed point formula, and this is the value of the function, and this is the estimated error. And remember that here I am not here I am not using this vector as a separate vector z. This is your choice. Okay, in this case I have chosen not to use it like z and then just put z over here. So similarly here I just showed two values. So in this case I have now printed out two values of the table. Okay, so let's try it. So clear, and now I run it. So I can see that I have printed two values. So one, xi is first estimated root, the value of the function at the first estimate, and the estimated error, which is of course 100% in this case. Now here we can now I want to apply the loop, but for this loop I should have the updated value of the xi. So the simple fixed point formula is like this, because x is equal to xi is equal to g of xi, right? So for this loop, then for the that means for the next values which I want to obtain from this for the second, third, and fourth iteration, we should use the updated values of x. So in this case, if we are using the g of x, but that g of x will be evaluated with this previous value of x. So therefore, I have to update the value of xi for the next iteration. So now what I can say that while EA is greater than ES, then first of all we'll calculate the error. So the error will be, in this case, in this while statement, I can copy and paste these commands. Okay, because this process will be repeated. Okay, so I can copy and paste. So in this case, let's read it. So while EA is greater than S, now I will calculate the EA again, because previously this EA was calculated with the previous value of xi, but now the value of xi has been updated with this gxi, so therefore there will be a new value of the EA, that is the estimated error. And with that I will update the counter I is equal to I plus 1, that is just the counter or the iteration, and then I will print all the values. Okay, like this, all these values which was previously required, that I will print. And the last statement is that before exiting from the while loop, we have to update the value of xi. Okay, we have to update the value of xi, and then we will end it. I will end it. So in this way, hopefully the script has been completed. And now let's run the script. Run the script, and then I can see that you got the values. So I can confirm that I have got the values correctly. 100, yeah, 171, then 46, 38, and then in the end, in the 10th iteration, I got a estimated error of 1.11. Okay, and in this way this was calculated. So in these two methods, that is this simple fixed point method and the false position method, we have seen that we actually first calculate the first two iterations, and then we calculate the other iterations from the while loop, because the loop actually starts from this first iteration.